Hello everyone, and today I'll be doing my presentation on types of stars, and I hope you enjoy. Okay, let's get started. So, what are stars? There will be a card on screen for further detail, just right about now, boy. But in a nutshell, they are giant balls of plasma powered by nuclear fusion. It's a pretty simple answer. Types of stars in temperature. These stars are determined by the Hertzsprung-Russell diagram, which was made by Ejnar Hertzsprung, sorry if I butchered that, and Henry Norris Russell in the early 1900s to classify types of stars by temperature and color. Red stars are classified in the M category. This category is the most common and is the coldest of the standard categories because of less nuclear fusion and usually not having as much mass as other stars. The hottest and rarest of the bunch are the O and B types, which are much denser and have more pure hydrogen and helium ions than other stars, reaching 10,000 to 50,000 degrees Celsius. That's extremely hot, oh my goodness. And that's just the surface. So imagine the core. Dang, that must be really hot. Our sun is a G-type, so it would be right around here. Yeah. Types of stars in size. Red giants, supergiants, hypergiants, quasi-stars, and protostars absolutely dominate this category, as even the smallest red giants are at least 3 times the size of the sun, while the biggest hypergiants dwarf the sun by thousands of times, like Stephenson 218, which is big enough that if it were placed in the same spot as the sun, it would engulf Saturn. That's massive. But the true kings of star size are quasi and protostars, which are so mind-meltingly huge that even at light speed, it would take 9.25925 hours to travel across these titans. That's massive. Which means the where am I? Oh, sorry. I moved to the sentence. That would be up to 66.5 astronomical units, or 10 billion kilometers. That's massive. That's really huge in diameter, which means it would be a black hole at the core of quasi-stars. And the reason why there wouldn't be a black hole at the core of protostars is because it's the beginning stage of a star. So protostars is when this star is beginning to form. So that means it's not that dense to be officially a star, just like a baby beginning star. You know what I'm saying? Like a fetus star. So yeah, it's not like that packed together to be considered like a red giant, or yeah, it just slowly, you know what I'm saying? You know what I'm saying? Quasi-stars, but they would still fit nicely in our 80 astronomical unit solar system. So that's big. Types of stars and functions. There are many varieties of stars in this category, such as boson stars, which are made up of boson particles like photons, gluons, and axions. We're actually not what am I saying? We're actually not sure if axions actually exist. We're still looking for them. I think it's a theory right now, but we're still looking for them. So, but there is probably a chance that boson stars do exist. Like, I think these are illustrations of boson stars and black holes. Like, boson stars and black holes are actually very similar. Like, both of them. My headphones just plugged out. Sorry about that. So yeah, both of them can have accretion disks. So yeah, they're very similar to black holes, except they don't have a singularity. So this is a black hole and this is a boson star. But again, they're illustrations. So yeah, and again, I'll have a video for each star that I mentioned. That's the challenge, guys. So that's further in depth, because this is like a simplified presentation, so that it doesn't take too long, you know. But yeah, hope you guys still enjoy. Which makes it seem invisible and can be manipulated easily. Neutron stars are extremely dense remnants of massive stars, which are made almost purely of neutrons and even has an atmosphere and crust, just like a planet. That's cool. Because it's so dense, right? And also because the core of the star, the dying star, was iron. So yeah, so it was kind of something. And finally, the iron stars, which will form in the degenerate era 100 trillion years from now. So don't worry, guys, that's a very long time. If protons don't decay, and since iron is the most stable, it will not decay into anything else. So in the future, there may be giant balls of iron everywhere. That would be crazy. Just so imagine we could live forever, which means that maybe at some point we would just turn into iron statues. You know what I'm saying? If it works that way, it probably will. But yeah, it's both these stars and all these stars right here. They seem scary, but they're pretty amazing, you know. So the end. Well, I really hope you guys enjoy. I know that I may have left out some other stars like white dwarfs and black dwarfs, so I'll probably cover them in a part 2. But I still hope you really enjoyed this one, and that you learned something new, and that you have an amazing day. And I'll see you in my next video. Bye!